Okay, yesterday you learned a little bit about the ideal gas law and ideal gases in general. Today we're going to focus on solving problems using the ideal gas law, P times V equals N times R times T. Now we've been using PV and T in previous equations. Now we're going to bring in the actual amount of the gas that's present as measured in moles. And this is just looking at one set of conditions, and the R is what we call a constant that allows us to relate these four different conditions. As always in this chapter, temperature must be entered in Kelvin, and for this equation only, pressure must be in atmospheres and volume must be in liters. We've given you the R value that is good for the units being liters, atmospheres, moles, K. If we wanted to use some other unit of volume or some other unit of pressure, you would then have to use a different R value. So rather than giving you several different R values and you trying to figure out which one to use, just make sure that your pressure is in atmospheres, convert if necessary. Your volume is in liters, convert if necessary. And the temperature that you plug in and the temperature of your answer will both be Kelvin. If you need to, convert back and forth between Kelvin and Celsius. So here's our first problem. What pressure in atmospheres, so I don't know pressure, 18.6 moles, that's my N, 12 liters, that's my volume, and 318 K, that's my temperature. So in this case, all of the things are already in the proper units. So P times 12 liters equals N, 18.6 moles, times the R value times temperature. You must, in your work, rearrange the equation to show me what P equals, what exactly you are putting into your calculator. 18.6 times 0.0821 times 318 divided by 12. Everything except, where is it here? Atmospheres cancels out. So your unit, 40.5 atmospheres, is the pressure. Now, I'm not going to make your life that easy with all the problems. So when you read the problem, the first thing you must do is say, are my units in the correct units? No, they are not. I cannot plug in milliliters. I cannot plug in kPa, and I cannot plug in 72 degrees C. So convert your milliliters to liters. 1 liter equivalent to 1,000 ml. Convert your kPa to atmospheres. Remember, the atmosphere equivalents, 1 atmosphere, 101.325 kPa, 760 millimeters, can be found on the gas chapter reference sheet if you don't remember them. So kPa becomes 1.56 atmospheres. To convert from Celsius to Kelvin, I'm going to add 273. So now I can plug the values into my equation. 1.56 atmospheres times 0.0369 liters equals N times 0.0821 times 345. Again, rearrange the equation to solve for N. So I divide both sides. This is what I am putting into my calculator. 1.56 times 0.0369 times 0.0821, divided by 0.0821 divided by 345. Now remember, you are solving for N. N is not grams, N is moles. So the answer that you get is 0.00203 moles of CO2. But I didn't ask you for moles, I asked you for grams. you can't solve for grams directly. You use the equation to solve for moles, and then convert to grams using molar mass, as we have done many times before. So I take my moles of CO2, my molar mass, I add together the mass of 1 carbon, 2 oxygens, 44 grams per 1 mole. So 0.00203 times 44 equals 0.08931 grams of CO2. So some important things to remember. You must plug in the proper units for volume, pressure, and temperature. Remember that the equation does not solve for grams, it solves for moles. So if you need to find grams, first you find moles. If I give you grams as part of the question, you cannot plug it in as grams. You must change it to moles before plugging it in to the equation. Your homework is going to be the ideal gas law problems. I'm going to assign it in 2 segments. First, problems 1 through 5 are due on one day, and then 6 through 10 will be due the following school day. Okay, so hopefully you've paid attention. These problems can also be found. You don't have to rewatch the Edpuzzle. You can see these same problem solutions in the PowerPoint that I've posted on Classroom. Okay, so good luck with the problems. Make sure you show all your work. Thank you, and have a good day.